hit me up, join. I have a slide. That very easy. He told me specifically, Dipsy was how it was pronounced.
Thank you, Matt. I'm going to turn off these front lights, or turn them down. All right, hopefully we can see that a little bit better. And can you switch this over to slides? Yeah, it is more fun. You all can guess what I am saying, or what I'm seeing.
Slides.
One moment.
It's this screen, so you change the screen? Yeah, I don't know. Let's just change the screen so it switches it out.
Almost.
Oh no.
Ooh. Fancy. So while we're waiting for that to get figured out, I'd love just hands from the audience. Who is currently working with AI? Who has used it in day-to-day, maybe to write some code? GitHub Copilot, anything like that? Awesome. At least 75, 90% of the room. Now, who in here has actually deployed or actually called AI from code? A smaller group. Well, I'll go ahead and get us started a little bit. Our talk today is DSPy from musings to modules. The whole idea of this talk came from just the fact that am I still in the meeting? Or did I leave? Is that the problem? One moment. No, I am still in there. So the idea of this talk came because I have been building AI with more traditional tools, namely LangChain, OpenAI, SDK, all of these for the better part of a year and a half. There was a weird middle part in there where I became a dad, so we had a few weeks off. We don't talk about that. I am Ben McCone. I'm a senior software engineer here at Source Allies. I really love AI, and I've helped bring multiple Gen AI solutions to production. Not just the proofs of concept that we've heard a lot of people building, but truly to production. And so this is a culmination of lessons I've learned and how DSPy solves some of that along the way. And fun fact, I am a contributor to multiple open source AI tools, some of which you'll be seeing today. So let's go ahead and jump in. We've all, I would say, a majority of the room has done traditional prompting, whether it is going to ChatGPT, talking with GitHub Copilot, or using these tools. And this is what that typically looks like. We are just sad. We realize very early on that prompts, they're easily broken. They are time-consuming to create and sometimes to execute. And oftentimes debugging a prompt will trade one problem for another. Let's go ahead and dig into some of those problems. First, prompts are fragile. The first thing that we learn is we need to call GPT 4.0 or 4 Mini, 3.5 Turbo. There are many different models, but what they don't tell you is if you don't specify this date right here on the screen, you're actually getting whatever the latest model is. And if you've ever auto-updated your dependencies and gone to production, you know that doesn't always go well. These are actually different models. They are trained very similarly. That's why they don't get a whole new name. But they have different inputs, different outputs, different steps in the middle. And these companies are very closed source. There are some companies that are open weights. Very few are open with how they actually do their training. DeepSeek out of China is, ironically, one of the most open AI companies out there. Meta, also very open. These are companies building in the open. So because of that, prompts are fragile. You may think that you can go from the August release to the November release. Not always the case. The way to fix that, by the way, is run evaluations. Make sure that you are measuring the outputs quantitatively. The prompts can be time-consuming. We see two wastes of human time with prompting. One, feels like we're in English class. We have to find the right set of words that solves the problem without being too wordy, adding too much context. Or, in worse, making an assumption that the model will understand something that's in our head that we have not explicitly stated. All of these things cause models to degrade. On the inference side, just breaking down to the math a little bit, I promise we won't break into the math. If you do want to know about the math, talk to Jacob Danner in the back. He is a genius, all things inference. What we need to know is that when we're talking to an AI, our words get turned into a bunch of numbers. Those numbers go through a lot of matrix multiplications, one matrix multiplication per token. And a token can be thought of roughly as half of a word to a full word, depending on how long that word is. The more input tokens, the higher this actually costs us, and the more likelihood that it's going to fail because LLMs only have so much attention or context. They may tell you, we can hold all of the books that humanity has ever written in memory. You're not going to remember that. Just like cramming for a test back in school, AI suffers the same fate. And then debugging pains. When you are fixing or patching an issue, you say, hey, don't exhibit that behavior. It, a lot of the times, will look like you are fixing a leaky pipe. What that may look like is you put some tape over here and another leak pops up over there. It feels like a never-ending battle. So, this is what a prompt today might look like. This is exaggerated. I don't expect anyone to read the whole thing. But this whole first paragraph, pleading. Please don't mess up. I need you to do one simple thing. In the middle, this is what I need. Just simply tell me if, based on the context that I give you and the statement that you gave me earlier, did you say something factual? And then finally, just for good measure, a threat. If you fail to follow instructions, we're going to shut you down. Now, this isn't fun, and after the 50th or 60th prompt, I thought, surely there's a better way. And there is. Enter DSPy, the topic of today's talk. Now, those of you, is there anyone in the room that has heard of DSPy? Awesome. A lot more hands than I expect. But for those that did not raise your hand, this very long description is from the DSPy's website. Let's go ahead and just look at a tweet from DSPy. It's a declarative framework for building AI systems, translates your code to your prompts, or fine-tuning. We're not going to touch on fine-tuning today. So, DSPy is really 4 to 6 controllable aspects that we can tune independently. We're going to cover 4 on this slide. There's the LM, the language model. That is, again, the GPT-4o, 4.1, Google Gemini, DeepSeek R1. All of these, they're interchangeable. Just change that one line right there. Signatures, these are an alternative to prompts. So here it is cut off a little bit, but we actually can define by a string, by a pedantic class, or a couple of other things, what our inputs and outputs are, what they should be, what they should look like, etc. And then I skipped over adapters. Adapters, you never really have to change these in DSPy, but they let us change whether we're chatting, we are asking for a JSON output, etc. By default, DSPy ships with a chat adapter that falls back to JSON if it is unable to give us our structured output. And then finally, modules. What is our prompting strategy? So now there's a few different prompting strategies. We will cover these. The basic is you just ask a question blindly to an AI, it responds blindly with an answer, and we all go on our merry way assuming that nobody lied to one another. Let's go ahead and expand this a little bit. Now we can see the full context here. This signature, we say that the context is a list of strings. We have a generated answer that was given to us, and we want factual to be returned as a Boolean, true or false. The nice thing here is we can then say correctness. We're using that prediction, which again is that zero shot. We are just asking a question blindly and getting that back. We also could do a chain of thought, which is another prompting strategy we will talk about later. And then you can call that just like a Python function, saying, here's my context. The sky is blue because of the way sunlight interacts with the atmosphere. The generated answer, it said, the sky is blue. And our output is a Python Boolean true. By the way, this is the same setup as that really long, exaggerated prompt a few slides back. This is the exact same thing in DSPy. So, why would we use DSPy? If you have worked in AI long enough, or if you've been on the internet really in the last 6 months, you've heard of vibe coding. I personally am sick of it. I've been in AI for over a year, and I'm sick of the vibes. I want to be able to trust these systems. And so DSPy, it brings a precedence for systems engineering, not vibes. We're writing Python code. We're not writing paragraphs of text. Evaluation, which I mentioned briefly earlier, it's a first-class feature. It's built in. We pass our data set, we pass our program, and DSPy says you're 86% correct. And then finally, DSPy can optimize on our behalf, but this is not required. These last two pieces, evaluation and optimization, these are the two pieces that we did not touch on this slide. And another reason, I guess, why we would want to use DSPy is, as I mentioned, the ability to switch between models. This is a screenshot from the Databricks AI Summit a couple of months ago. Drew Bronig, he works at the Overture Map Foundation. He gave a talk about just DSPy and why we need to let the models do the prompting. In his example, he took 3 different models, Qwen 3, Llama 3.2, and Phi 4 Mini. These are all open models that we can run on our machines. In fact, I have run 2 of the 3 of these on that MacBook in the last week. And it brought the same problem set from a 60% out of the box to 82% on Qwen, 84 to 91 on Llama 3.2, and 86 to 95% on Phi 4 Mini. The benefit is he did not have to change the production code to make those model switches. He just had to rerun optimization and let the model figure out what is the best way to solve this problem. So let's go ahead and get out of a slide deck. Nobody loves a talk that is entirely slide deck. And let's actually go ahead and look at some examples within VS Code. How's the font size, everyone? Bigger? Good?
Bigger.
Bigger.
I promise I use technology. How's that? All right. So we are also going to be using an open source open telemetry collector called Phoenix. Phoenix is created by a company called Arise. I recently spoke at a conference of theirs out in San Francisco. And the really cool thing is we can run this all locally. So what I just did here was auto instrument, meaning we're going to be able to see what DSPy is doing under the hood. Next, we're going to create our language model. In here, we're using GPT-4.1 Nano. And then let's go ahead and look at signatures. All of this code will be available on GitHub after the talk. Feel free to hit me up and we will share that out. So in here, the really cool thing is we're just creating a DSPy signature, question, arrow, answer. We don't have to provide types. We don't have to provide any of that. But if I run this, that will go out to OpenAI, and it will say Iowa became a state December 28, 1846. Now we're in Iowa. Does anyone know, is that correct? I assume that it is. I've never fact-checked this. Moving on, we can also create signatures with type with types in them. This doesn't actually change anything because the default is a string, but we'll see examples later on where we can actually define very complex types that DSPy then enforces that we adhere to. And we can see that this returns a prediction object saying fireworks were invented in China around the 7th century. Based on this question, I'm sure we can all guess that I was putting these examples together on the 4th of July as my 1-year-old was being kept awake by the war zone that was outside my home. But strings, we're still writing strings. This is better. It's not great because we still are at a point where I have to know the question, arrow, answer gives me a question-answer pair. And that's where we can start using signatures that are built out of classes. So DSPy.signature, we saw that up above, but now we're actually subclassing it. And there's some really cool things here. If you, like me, are a recovering prompt engineer, you still want to know, yes, Ben, but there is something that I want to tell the model explicitly. Well, here I am to tell you, docstring. The docstring is your prompt. That is passed to the agent, and the truth is, these agents are smart enough, just write it like a normal docstring. If you're writing your documentation in Python, which you should, you're going to get 90% of the way there out of the box. And then, just like any other class, you define what are your types. The only thing that is different, you add your type inference or your type hinting. This is a string, this is an optional list of strings, is what we set the value to. There are 2 special fields. There's more, but we'll stick with 2 for this talk. DSPy.input field and DSPy.output field. You can have as many of each of these as you'd like. You want to use them sparingly, as much as you need. Don't worry about adding too many. You'll know if you've hit too many. And then in here, you can also add a description to your fields. So the input field has a description of a list of contexts to answer the question from. The actual answer that they are providing to us has a description. Realistically, it doesn't need this description, but I added it as an example that it is available on inputs and outputs. And let's run this with a prediction that is just, what is DSPy? And for this, we're not going to provide any contexts. Awesome, it did fail the way I wanted it to. So OpenAI believes that DSPy is a Python library, correct, designed for digital signal processing. Incorrect. I believe that is an electronics term with like an oscilloscope. I could be wrong. I don't know much about that. I do know that DSPy is not that. And this is where we start to see that DSPy can easily be extended to use a tool or a technique in the AI space called RAG. This is retrieval augmented generation. And what that means is out of band, whether this be fetching data from your database, scraping the web, or many other techniques, giving it other information alongside your request that it can pull from. And this, I just grabbed that full string, those few paragraphs from the DSPy website. And let's go ahead and run this again. What is DSPy with those contexts? And now we see that OpenAI says DSPy is a declarative framework for building modular AI software that allows for yada, yada, yada. It got it right. This is awesome, and we've written minimal prompts. We have not had to worry about getting things formatted just right for AI to give us an answer back in a form that we want. Before I move on to modules, I do want this to be interactive. Are there any questions so far? Yeah.
So I came into this kind of blind. I looked a little bit up, but I'm getting what you're saying now about like kind of the advantages of it. But then maybe I'm spoiling the punchline a little bit. But like jump me ahead now. So as you talk about this stuff, what am I supposed to be thinking about? Like, is this going to be when I have a complex prompt, I get a better result faster, or is this going to be like I want to rerun the same prompt a lot for some reason? Like I don't think I'd run the same. Like I usually do stuff like when did Iowa start?
Yeah.
And I'd have my answer and I'd be done. So I don't need to rerun the prompt. So I build all this, but I just ask it once and be done. So which way is it though? Are there reasons you would want to keep re-asking something, or is it more like you get there faster because you've already got some stuff built?
That's a great question. For those online, the question was, why DSPy? If I'm using AI and I'm going to ChatGPT, why would I use DSPy instead of ChatGPT or similar tools? Because I'm asking these questions once and never again. The answer for you is, great question by the way, is this tool is not meant as a chat interface. It's meant for building AI systems. So think your production application in an enterprise that needs to start augmenting human work, performing reviews of existing tasks. Those kinds of things are things that are running thousands or tens of thousands of times a day. And that's where this is really helping. And you do get to cases where you're running the same thing tens or hundreds of times, even with the same inputs and outputs. It's called evaluations, and we will get there with some examples here later in this talk. All right. You good? All right, let's go ahead and go down to modules. Modules, I alluded to this. So far, we have only used predict. There are 4 others that I will briefly mention, just what the benefits are, and for the rest of this talk, we'll be using 3 of them. The others are chain of thought. An idea had surfaced a year or 2 ago that if we let AI think and reason, it generally provides better answers. Just like a human, talking through helps. And that's what chain of thought does, is it adds reasoning to that answer. React, this is where all of the hotness in the AI world is right now. React is one of the structures for an AI agent and gives AI tools that it can then call to actually make changes outside of its matrices of numbers. There is also DSPy program of thought that is not actually, I don't have an example of that, but it's like chain of thought, but instead of thinking in words, it's thinking in code and actually running Python code behind the scenes. Really cool. And then there are more modules that can be found in DSPy documentation. This can be anything from best of n, where you're giving it an evaluation at runtime, a reward function, and you're saying, give me the best of 5, or the first answer that exceeds a 75%. Continuing right along, let's go ahead and look what chain of thought does for us. Now, if you've heard of the strawberry problem, AI, hilariously, can't count the number of R's in the word strawberry. So this first one is a basic prediction. There are 2 R's in the word strawberry. Now, I as a human can count, there's 3. But if we let it reason, it goes and it talks through it. It says the word strawberry contains the following letters. It puts them out each individually. And then at that point, it can say that the answer is 3 correctly. All just because we gave it the ability to think before it answered. Going right along, another thing that AI is hilariously bad at is math. Sometimes it gets that question right. Oftentimes it does not. So what this tool is, this is not very exciting, but what it does is it creates a math agent where this is a normal Python function, by the way. It just has a DSPy tool annotation, and that is actually optional. I can talk about that later if anyone's interested. And then we just give it all of the type hints. X, Y, operation, and that operation has a literal with plus, minus, multiply, divide, and exponent. So with this, we create a signature just like we did anywhere else. This time we say we actually want our answer as a float. We do not want a string. We want to be able to use this number elsewhere as a number. And then we build a React agent with our signature, and we give it a list of tools. I mentioned earlier that tool annotation is not needed. DSPy will convert a few different things automatically to a function. Python functions are one of them. It also has native support for MCP, Model Context Protocol. This is another big name out in the AI space right now. It can also use LangChain tools out of the box. So if you have heard of LangChain, it is the big kid on the block that just had crazy valuations out in Silicon Valley. DSPy can handle those tools and natively use them without modifying them. So we created that agent. Let's go ahead and see what that looks like. In here, I'm asking the question, raise the largest prime number, less than 100, to the power of 2. And let's see what AI does. This is going to print the trajectory. The trajectory is the actual tool calls that it's using, the actual reasoning that it used, because it, again, is using chain of thought under the hood, and then our final answer. This will take a little bit, and we can see React is built up of a loop of observe, think, act, observe. It goes in those 3 tools over and over again until it comes to an answer. And we can see observation 0, 9409. Oh, thought 0, the largest prime number than 100 is 97. I need to calculate 97 raised to the power of 2. From there, it calls the tool do math with these arguments. From there, it then gets this observation 9409. From there, it calls the finish tool, which does not take any arguments. The observation is completed. From that, it can see all of this output, reason about what the answer is, and then finally return us the number 9409, again, as a float that we can then use elsewhere as a float. Very cool. Now this next example is a little bit contrived, but I did want to show people MCP and what it's really capable of. This is not a practical example, but I put this in the wrong window. Now, hopefully the demo gods are with us. I actually have a wise cam set up at home pointing at a lamp in my living room. And we can see it is currently turned off. And we're going to go ask it how to turn it on. This is not a practical example, like I said. We're using GPT-4.1 Mini. And can you turn on the living room lamp? And because my home assistant, home automation is hooked up to the internet, I have API keys in my environment variable, and we have this prompt, this signature rather, that tells it a little bit about what is in my home. I have a very short, call it 15 or 20 lines that are now going in a loop. It keeps all of my history, the questions and answers in an array, and it's passing that back and forth between me and OpenAI. Now let's tab away. Oh no, it did not turn on. What did it do? It is attempting to turn that off. Demos may not be with us. Try again. If this doesn't work, we'll give up on this MCP, but do know that this was working. Can you please turn on the lamps? Okay. One more time. Yay!
Woo!
Good try. And just so I don't scare my cats, turn the lamps off.
Now it won't work.
And we'll wait for that just so that the cats don't get scared. It is back off. Awesome. We will go ahead and type exit. And that is the end of this notebook. How are we doing on time? Great. Now I want to talk a little bit about evaluation and optimization. Before we go over there, this is another big milestone in the DSPy learning journey. Are there any questions? Yeah?
I know you gave it a do math tool. Have you thought about just giving it a tool that wraps eval in Python?
Yes, the question is, I saw that you gave it a do math function. Have you thought about giving it a tool that just wraps eval? Yes, you can do that. Please don't. If you do want to execute Python, like I had mentioned earlier, there is a program of thought module. And the really cool thing about that is it downloads, or it does not download. You have to provide it a Dino node environment. And through that, there is a Python interpreter that it can run through Dino. And from there, that's a secure environment that you can control what packages it has, and more importantly, not give it access to your system. you can give it access to your system. I have. Be wary. Just be careful if you do give AI unfettered access to your system. Recently we saw, I think it was Replit, their AI agent deleted production databases for a startup. And that was a very costly mistake. So, with that, let's go ahead and talk evaluation. Now I am going to say in this talk, or in this slide, in this notebook, we are using a different provider. We're using OpenRouter to run a very small version of Meta's Llama 3.1. We're specifically using their 8 billion model. This is a model that I could run feasibly on my MacBook at a speed that would not be untenable. Again, let's go ahead and go into Phoenix. Before we do this, I realized I have not shown anyone Phoenix. I mentioned Phoenix earlier. This is the UI. I have it running locally. And the cool thing is we can actually see what is happening under the hood when we talk to DSPy. Something that I think is really cool.
Could you zoom in a bit?
Yes. How's that? So we can see from the top, React calls a forward, predict calls a forward. It goes all the way down. The zoom is making it so they are collapsed and we can't see the hierarchy there. But we can actually see at every level what is going on, even down to, let me zoom out the other way. This is what that prompt from DSPy looks like. Here are the tools. It's saying here's what you need to call out. Here's the next tool name. Here are the arguments. When you're done with your message, say that you are completed. And then down here, this is that prompt that the doc string that tells it the information that I did need to provide as a human. It has my family room lamps, home assistant, entity ID, the thermostat, the fact that I have a home NAS, and it has 2 pools. So if anyone's interested in home labbing, feel free to talk to me after the show. I love to geek out on that stuff. But the important part is I didn't have to write 90% of this prompt. And even better is if it fails, DSPy automatically retries with a different adapter like we talked about earlier. It will fall back to JSON. It will tell me that, hey, I couldn't do it one way, I'm gonna try again another way. Awesome. Yeah, I said I didn't write 90% of this. I don't think I wrote 10%. I don't think I wrote even 10% of this. It is massive. Here, one more thing. We see React has the predict call. That was the first tool. It actually called entity action a call that is from the Home Assistant MCP server. The second prediction is to call that finish tool. It called finish. We called chain of thought on that answer. It called an LLM. Let me zoom out. And then it finally said, here's my reasoning, here's my answers. The lamp has been turned off. All right, now the moment of truth. We have set up our tracing, we've set up our Llama 3.1, and let's go ahead and create a data set. While I'm running these, there are a few things that I need the group to know. One, I don't have a lot of data to train a model on. So optimization, it is optional. The DSPy team, they'll tell you that this is a maybe. You don't have to run optimization. I will say that evaluation, if you're going to production, is a must. So in this, we have a data set. I downloaded this from Kaggle, and it is a simple classification of support tickets. So I'm sure at work we all have a system like ServiceNow or similar, where you have to find the right form. Inevitably, if the wrong form, it goes to the wrong team, and you're spending 3 days to track down who does this go to, so I can get a role added and get into Jira and do my job. So this is an idea of, what if we had one form, and we had an AI that just automatically routed that to the right team? I didn't have to think about the right format. And so in here, this format is, or this file is exactly that. It is phone calls or emails from a customer. Would it be possible to cancel the order? What was their intent, and what was their category? That's loaded into a pandas data frame. We have a DSPy signature. I have a type here that is all of the valid categories that it could be sent to, and then a very simple signature. determine which category best fits so that we can send it to the right team. The input is that customer utterance. The output is the ticket category. And we're using, again, that simple prediction. We aren't even giving AI the ability to think about its answer. From there, if you've ever done machine learning, there is the concept of a dev set, a train set, and a test set. In this, I just have a train and a test set. Let's go ahead and run those. Those get put into DSPy examples. And these are so that DSPy can pick up your data set, send it to AI, and then evaluate the answer with code, again, that you wrote. Oh no, I deleted evaluate accuracy. So we're going to write that really quick. This is an evaluation. Def evaluate accuracy.
I think it's saved as markdown right above that.
Thank you. Thank you. Edit. Python. Run. I swear I have done Python before. So right now in this, we evaluate the accuracy. We actually create an evaluation object. This has our dev set, which is our test examples. It has our metric, which is just saying, does the ticket category match on the example and the predicted? And then I say display the table at the end and display the progress. So we see over 135 results. We have an 87% accuracy. Not bad. Probably doesn't beat out my ability to find the right ServiceNow form. And then in here we can see right here, this was an account question, but it said that it was a contact question. We could dig through and figure out where it went wrong, but this is more fun. DSPy has a bunch of optimizers. The latest and greatest is called Simba. I'm going to run this now because it will take a while, and it's going to output a lot here. So in here, I've actually pared this down to max steps of 4. That means it's going to go through 4 optimization runs. The default is 8, and then a batch size of 16, meaning it is going to try and make 16 different candidate programs every single time it does this loop. And when it's doing that, what it's actually doing is it's internally asking the AI, do I need more examples, or do I need more instruction? And from there, it will automatically write that instruction, pick out those examples, and add those to our prompt on our behalf. So while this is running, this will take a minute or 2, but let's actually go ahead and look at one batch. So we are processing bucket 7, it has a max score of 1. So on that test set that it's testing against, that batch did very well. We can see here the advice to self. When processing the customer's utterance, consider using, if this will stop. Is there a way to get this to stop scrolling while it's running? We'll see. Let's see if I can find that again. Here, when processing the customer's, let's copy it out. All right. When processing the customer's utterance, consider using more advanced neural language processing techniques, such as named entity recognition or sentiment analysis, yada, yada, yada. We, again, don't really care. We care that we are performing well on our data set. How the model needs to hear that to be accurate doesn't really matter at the end of the day. What our stakeholders care about is that it is accurate and that we're able to deploy this and have it be repeatable. So back here, it is on batch 3. Maybe I should have made this shorter, but we will, while this is running, any questions from the audience about what's going on in the background? If not, I can monologue and talk a little bit more about what it's doing and just guess those questions. All right, so in the background, this is creating a bunch more of those modules. That means that it is taking all of those prompts, it's adding instructions, it's adding examples, and then at the end, this seems to take a lot of time and a lot of tokens. It doesn't take a lot of tokens. This run will probably cost 2 or 3 cents. But then we can actually save this out to a JSON file, which would be committed to our repo. We would then publish that on Git, and at runtime we would load that in happens so that these instructions of the optimization are there in production and are being used until our data set inevitably changes next sprint when, well, we standardized on these 5 other departments. Ask me how I know. Yes.
I think I missed something as you were going through. Accuracy was like 87%.
Yes.
Accuracy compared to what?
Yeah. So the question for those again online are, how do we actually validate accuracy? In this case, there are many different ways that you can measure accuracy of your specific AI solution. In this example, I downloaded a data set. In the case of an enterprise doing this for real on something like ServiceNow, you have actual ticket backlogs that you can comb through. You can say, this is the original message that somebody pasted in. This is the queue that it ended up in at a finalized status, and that's your data set.
Gotcha.
What was the request? What was the group that solved that problem? That's your data set. Going down here, we define the actual list of data sets, and then this is probably the simplest possible evaluator that you could build. Anything that can go in a Python function that returns either a Boolean or a number between 0 and 1 as a float, that's a valid evaluation. There is even more that can be done. Simba, I mentioned, is their brand new optimizer. This was released at their Databricks AI Summit a month and a half or 2 months ago. And the cool thing is this model gets the full output data frame that we saw here. It's not looking at each one of these every time it's looking at one row, but we could return a string. If we know what's wrong, we could just return a string that says account, or the I'm a customer and I want help signing up. Up, we could just say, oh, up was transposed. It should have said signing up. Be on the lookout for spelling mistakes. And the AI would take that into account. Another really cool thing you could do is the input function. If you want a human evaluating every single one of these, you can. Let's go ahead and check on that result. We are almost done. At the end, it runs through your entire training set through, in this case, 5 programs. So it is, give it about another minute or so. Demo gods are not with me tonight. It is, I'm sure, Wi-Fi, and a lot of people are wanting to use Llama 3.1 8 billion tonight. But when this is done, we'll get to see the final score as of the training set. But as we've all seen in AI, they are, every model release says, we're topping the training set, the benchmarks are looking great. Well, I don't want to repeat the mistakes of them. What those companies are all doing is they're training on the test data. And that's not great. If I had a test, yeah, I could study just the test and say the answers are A, B, C, D, E, F, whatever that may be. The real value of these evaluations comes in when you can get those same results on other data that this prompt has never been tested against. So we are just about done, and we'll see what evaluations say. So it looks like for the training set, the best was about 96%, a massive improvement over what it was. And again, just for good measure, let's run an evaluation over that 135 question set, which is completely different questions were not in that data set. And yeah, it's holding true. We'll see where it lands. We're definitely above where we were. Looking maybe 94 to 95 is where I would expect this to end up based on what I'm seeing. And so yeah, a marked improvement. As I had mentioned earlier, this was a smaller training run. You can run training runs multiple times. Just like a data scientist building these models, not every experiment pans out. And so playing with the number of max steps, the batch size, the training data, all of these things can influence and produce different prompts. That's why it is important for us to, when we get one that performs well, save it to a JSON file and commit that to our repo so that we can load that in when we get to production. All right, that is the end of notebooks. We have 2 other quick slides. Oh, and just for posterity, let's go ahead and look. We just use 1.1 million tokens, which is massive. Not for a large enterprise, but for an individual, 1 million tokens. If we were using all OpenAI, that would be between $3 and $10. Pricing this out and testing it ahead of the time, Llama 3.1 is like less than 5 cents. So awesome. Big shout out to OpenRouter and cheap models. All right, so a couple of things that I want to leave us with. This is a screenshot that was traveling around Twitter a few weeks ago, and DSPy fits really well into it. Prompt engineering is out, context engineering is in, and DSPy solves so many of these bubbles in the Venn diagram. Prompt engineering, that has been the cornerstone of this talk. We don't need to do that. We need to be systems engineering. We need to define what is our problem and what inputs and outputs do we actually need. State and history, that one is a little bit questionable. They do have DSPy history as a type. That is something we were leveraging in the MCP example. RAG, that is something that we did not really touch on. There is a concept called vector databases in AI, and that is really the cornerstone of what most people consider RAG. The team behind DSPy has actually created many of these models, many of these techniques, and are constantly iterating on this. I don't think I said it, this library is out of Stanford, funded by Databricks. And then finally, structured outputs, that is DSPy's bread and butter. So 3 out of 4 of the small ones, I would say context engineering, pretty well solved by DSPy. In fact, the CEO of Shopify said DSPy is their context engineering tool of choice. I'll leave you with this meme. Tired of writing the bad strings? Learn DSPy and write the good strings. All right? And thank you. Thank you all for coming to the talk. That is what I have for you today. I'll be sticking around. Please come up, chat with me. And yeah, let's connect. Let's stay in touch.
So the optimization sounds cool, but as for like the predict and those other modules, it seems like a pretty decent like drop-in replacement for a chain or something like that. Is there ever a case where you wouldn't reach for DSPy in that type of programming?
Yeah, the question, just in case anyone here didn't hear or online if you're recording later, is all of this seems really cool. Optimization is awesome, but is there ever a case where we wouldn't use DSPy and we want to use a different tool instead? I would say the answer is yes. DSPy, one of the newest types of models that are coming out are voice models, those that take audio in and optionally return audio. That is something that DSPy does not have on their radar, and that is not something that is on their roadmap. So if you want to go into that type of AI modeling, DSPy is probably not the best. Image inputs are also a little bit shaky. They can help optimize, but they cannot create examples on your behalf. They cannot bootstrap examples is the terminology in DSPy. So those are the 2 of the places where I would not reach for DSPy. I would reach more for something like a LangChain maybe. In those very specialized cases, I would reach more towards whatever vendor you were calling, whether that's Amazon Bedrock or OpenAI, whatever it may be. I would probably reach for their tooling first and iterate there. Yeah.
Did I understand correctly that when you were doing that training run, that was to get, for a given model, to have prompts that work the way you wanted them to? Is that the general idea?
Yes, here I will actually, while we're here, model.json, the really cool thing on these models is they're save and load. And so the Simba model, it's just a JSON file, and it's not really a model, but we can see this is all of what the AI came up with. Instructions are to determine which category best fits. I wrote a lot of that. But then in here, let's bring this out to the file, and let's replace new lines with actual new lines. Oh, it's just the one, okay. Toggle word wrap. So this is what it came up with as that example. When processing the utterance, pay closer attention to the phrases that indicate a change or modification to your account. With a specific example, this can be a strong indicator of account-related issues. Consider using more nuanced natural language. We saw some of this in that example. The reason that it hones in on account, I run this evaluation a number of times to make sure that one, we were going to see an improvement, and two, it wasn't great out of the box. It really struggles with the account gap. And so in its instructions that it wrote, it honed in on account because it saw that it was getting those questions wrong more often.
So then, as a follow-up, what I'm wondering is, when you go to a new model, you're trying a different model, are you always starting from scratch to do your training, or are there like open source, JSON files or something to help you get started? For like, okay, we know that there are some quirks with this model that you're going to encounter, so this will get you, maybe the first 20%, or is it you're just starting from scratch? You have to do your training run?
Yeah, the question was, as we are switching models, are you starting with the same instructions? Are there open source collections of data sets that help you get started? Or are you starting from scratch? That is something that every situation will be different. It's going to be nuanced. If it were me, I would start with what that previous version of the model, how is it working? If this was working fairly well on 4.1 mini or Llama 3.1, let's try it. The models are similar, but there are big nuances. With one project that I saw specifically, going from GPT 4.0 to 4.1, which every benchmark says is an improvement across the board, it was not. I can just plainly say that it is not, and they are completely different beasts. And so I would start with what you have and see what are your evaluations telling you. Is the data set that is specific to your problem set? Is it performing well? If it is, don't change what's working. If it's not, that's where we might reset to baseline. We might try a few different things, including running another optimization step. But what DSPy gives us is the ability to migrate from one to another without too much manual effort. Yeah.
So like back to the .predict or those other signature things, are the prompts that we're getting out of those just like, is that basically like a Jinja template or something like that? Or are those written by AI?
The question was, are the prompts written by each of these built-in modules, are they Jinja templates? Are they written by AI? It's a mix. I think the most truthful answer is most of them are written by Stanford PhD students. Many of them will probably be using AI. But the important thing here is not how those prompts are written, it's that they are structured. So what I have found in using DSPy is oftentimes the results are better just moving into DSPy because the inputs and outputs are structured in a way that the AI is very good at following a series of steps as long as it has those examples. And that is the big benefit out of the box of DSPy, ignoring optimization and the like. Something I see a lot in the DSPy community is the question, all right, I can use DSPy to optimize my prompts. Now let me take it over to LangChain. That's not something I would suggest because it's a combination of the adapter, the chat adapter, the JSON adapter, there's a few others, as well as the module, as well as their signature. And those three things in combination are not very portable. What is cool though is the DSPy community has really rallied around the idea of DSPy should exist in other languages. That's why that meme had DSP, not DSPy. So today you are writing Go, there's DS Go. In Ruby, there's DSRU. There's 7 or 8 of them floating out there. Those are the 2 that are most interesting to me. I grew up on Ruby and I really want to use Go. And so those are the 2 that stick out to me. But there are, for most languages out there, there's also a TypeScript version out there. I believe it's called Axe. Breaking the naming convention. But yeah, if you're going to go into DSPy,